Hello everyone. I'm Pranav Karande. I'll be presenting the work conducted by me at the AI lab at the Department of Computer Science and Engineering, Indian Institute of Technology, Indore, titled GemST, Continual Learning for End-to-End Speech-to-Text Translation. So, an introduction to all the terms. Speech-to-text translation, or ST, is simply the problem statement of converting audio in a source language to text in a different target language. So for example, if I speak something in English and I want the transcript in say French, so that would be a ST problem. And continual learning compared to traditional machine learning or deep learning is the sequential training of a model as new data is introduced while retaining the performance on the previous data. So in traditional machine learning, you would have all the data you want to train on available initially, and you would train on it and you will have the final model. Whereas in continual learning, you are continuously getting new data and you want to keep updating the model to work on the new data as well as preserve performance on the older data. So continual ST in the context of speech to text translation, continual learning means addition of new languages while retaining performance on old languages. So for example, I have a model that can translate from English to French. Then I train it so that it is able to translate from English to Russian, but it should still be able to translate to the French language, and so on. I can keep on adding new tasks, so it should be able to perform the new language pairs while still retaining performance on the older ones. So we use the standard FAIRSEC encoder-decoder transformer architecture. It uses wave-to-vec and a CNN in the encoder for transcription in the source language speech to text basically, and the decoder is responsible for mainly doing machine translation, but it is an end-to-end approach. So now GEM, or Gradient Episodic Memory, is a method, is a rehearsal-based method for continual learning, which basically means that we have a replay buffer, what we call as the buffer, which a very small buffer, which will have the data of the previous tasks stored in it. So for example, if I have already trained my model on English to German data, and in the next task I'm training on English to French, then the buffer will have a small amount of the English to German data stored in it. And this buffer will basically be used to project the gradients in the current model training so that they are better able to they are so that they are better able to align with the previous gradients or the gradients of the sample stored in the buffer. So the data sets that we have used is MUSTC, multilingual speech to text corpus. It consists of TED Talks, which are in the English language, and they have been manually translated to several European languages. The data pairs that we have used is English to German, English to French, English to Russian, and English to Dutch. And these are the statistics of the various language pairs. So these are the results that we have. So we have taken 4 tasks, and in each task we are introducing a new language. The first task was simply training on German. In the second task, we introduced French, and so on. So the baselines we have taken are fine tuning, which is simply taking the previous model and the last checkpoint of the first task, you start training on that for the second task, and so on. And the joint approach is where you provide all of the data for all 4 languages at once, and you train it at once. And GEM is our approach. So we can clearly see that the fine-tuning approach is having completely catastrophic forgetting. So in the second and third task, the performance on the German language is completely deteriorated. And the metric here being used, by the way, is BLUE, which stands for Bilingual Evaluation Understudy. It is the standard evaluation metric used for ST tasks. So, and in the joint approach, which is the upper baseline, the performance on all language pairs is with our approach, that is GEM. the forgetting is alleviated by a significant amount. That is a 75% forgetting compared to 98% in case of fine tuning, which is the lower bound. And here I have plotted the epoch-wise blue scores. Uh, Here we can see that as new tasks are being introduced, the performance of the fine-tuning approach is completely catastrophic for all the tasks. And compared to this, GEM is able to retain performance on the previous pairs. And at the same time, even for the newer language pairs, the performance is slightly higher. This is due to forward transfer. So the conclusion and limitations of this work. So this was supposed to be a baseline first exploration of the topic of continual learning for speech to text translation. And we have successfully demonstrated that rehearsal based approach, that is GEM, can be used for this purpose. And we have opened up research avenues for further exploration of continual ST. That's it from my side. Thank you.